This is lesson 5.2, measures of central tendency in misleading graphs. The majority of this should be reviewed, so I'm going to go pretty fast. But again, the concepts can take a little bit to define and discuss, so it might be a two-part lesson. So pace yourself as we go through this, and definitely go ahead and fast forward if you are understanding the basic concepts of these first things. Alright, measures of central tendency. Okay, key here being central. Measure of center. Okay, so when we find the mean, in other words, average, right, we add up the data and divide it by the number of terms we have, or items we have. So if there's 6 numbers, we add them up and divide by 6. That centralizes all the numbers. So instead of having 6 different numbers, we have one number that measures the center. Okay, the median is, in a data set, the middle number or the average of the two middle numbers when the data are arranged in numerical order. So again, median, middle, but it has nothing to do with value, it just has everything to do with position. So if you put the numbers all in order, it's the middle number. So median has different value than a mean. Okay, so median has no value per se, it just is the number in the middle. The mode is a measure of center because it's the most frequently occurring item. So usually if there's a lot of one thing, that affects the average. So mode is again just the number that shows up the most. And yes, you can have more than one mode sometimes. Outlier, an individual value that falls outside the overall pattern in a data set. Okay, so if it's not the same compared to the rest of them. So if you have a group of data and one stands out, then it's called an outlier. So we'll take a look at what that means also. And outliers, very important point here, do affect the average or the mean. Okay, they don't affect medians or modes though. Univariate is what we're going to work on with this lesson. That's the analysis of a one variable statistic. In other words, you have a list of numbers, you just add them up and divide by the number of terms you have, finds the average, but it's one list of numbers, not two. That would be bivariate, and that's something we'll discuss in 5.3 and 5.4. Alright, so again, when do we use them? Alright, very important to know when to use which one. Because I just mentioned before that mean is affected by an outlier, but median is not. So if you notice, use the median when the data contain outliers. And we'll see what that looks like in a little bit. Use the mean when the data are spread out and you want an average of values. Or mode when the data are tightly clustered around one or two variables, which one shows up the most. That's where you would want to use mode. Okay, so here's a little warm-up, not a very big task. You are very well up to the task here, much up for the task I mean. So we have a list of numbers. In order for us to use medians, then we have to be able to put things in order. So if you numbered these from least to greatest, it'd be that order. Next, and you can pause this and do it on your own. Next list, put them in order. That's what you'd get. Next list, in order. Now notice this one has decimals. So to really compare decimals, you want to make sure that you look at the number that has the most decimals. In this case, it's 3.74. And then do the same for every number present. Make sure they have two decimal places. So 3 would be 3.00, 3.7 would be 3.70, 3.30, and then 37.00. So they would look like this. That's 3, that's 3.3, 3.7, 3.74, and then 37. And why do we do that? Because if we don't do that, it's harder to compare and to see which number is actually bigger than another. So you can actually then see right here, for example, that 3.74 is bigger than 3.70. Sometimes it's harder to decide when it's just 3.7 and 3.74. Harder to tell sometimes. So just a little trick of the trade. Alright, now let's take a look at this question here. Sorry for the ring there. Okay, 6 high school students are participating in a one-week readathon to raise money for the school. Use the graph to find the mean, median, and mode of the data in this. Listen, always read the directions. If you leave out Latina's pages. And here's Latina's. We're going to take that out. So we're going to ignore that. Okay. Mean. What we talked about mean would be to add up the numbers and then divide by how many numbers there are. And there are 5. So we would get 46.6. Add them up and divide by 5. If you're using a calculator, you might want to make sure that you put parentheses around this so you get the right answer. Median, well, since they're already nicely put in order, there are 1, 2, 3, 4, 5 numbers. So 2 in from each side would put this one in the middle. So that is our median. And they are in order already, so that was nice. The mode is the number that shows up the most. In this case, it's 50. That shows up twice. Alright. Mode. How many modes, if any, does each have? So for A, what shows up the most? If you look at them, they all show up the same amount of times, so nothing stands out, so the mode is useless. Next one, we have 1, 3, 4, 6, 7, 7. So 7 shows up twice, and 12 shows up twice. So you can say 12 or 7 and 12. Okay. Next one, you can do words even here. Tomato, tomato. Grape, orange, cherry, cherry, and another cherry. So if you're talking about what shows up the most, then definitely you're going to have to go with the cherry, since it shows up the most. Even though tomato shows up twice, cherry wins. Alright, outliers. We talked about outliers, and if you notice on the other page, we had 37 right here. In this list, definitely stands out compared to the rest. 3, 3, 3, and 3, 37. That would definitely be considered an outlier. So let's take a look at this one. We have 7%, 4%, 10, 33, 11, and 12. Now sometimes it helps to graph. So let's take a look at that. We have a 7%, so I'll put a dot where that would be. So 7% is about here. 4% is about here. 10% would be about there. 33% is over here. 11% and 12%. So when you graph it, sometimes it's easier to see. Very grouped between around 5 and 10, and then there's this one. So that is definitely an outlier. So does it have an outlier? Yes, 33%. How does the outlier affect the mean? Well, if we add these numbers up and divide by 1, 2, 3, 4, 5, 6, that outlier makes a big difference because 33 is not around where the other ones are. Okay, so if I had 33 in my calculation of the average or the mean, then it would pull the average towards 33. If I took that out, then we would have an average around between 5 and 10. But when it's in there, it would pull the average more to the right. How does the outlier affect the median? Well, the median is just a number, the middle number. It has nothing to do with value of the numbers. So it would not affect it at all. So it does not affect it. Using the mean in calculations. All right, we see this question a lot, and I'm asked this question a lot by students. Kamiko's mean score in the first 3 tests, so let's get some key things here. First 3 tests in his history class is 87. That's his average after 3 tests. There's 1 test remaining in the grading period. What score does she need on the last test in order to get an average of at least 90? I want to show you first the intuitive way of doing this, okay? And that would be to say, well, if they got an average of 87 for the first 3 tests, then what they must have done is they must have added up 3 numbers and divided by 3. So if I took 87 and I multiplied it by 3, I'd get what that sum was. And if I did that, I would get 87 times 3, and I'd get 261. That was the sum of the first 3 tests. Okay? Now, if I want to have an average of 90, of at least 90, after 4 tests, what must the sum be? So I take 90 times 4, and I'd have to have a sum of 360. Well, what's the difference between those? Well, 360 minus 261 is 99. If I subtracted those two numbers. So I'd have to score, or she'd have to score a 99 in order for her, or better, in order for her to get an average of 90 on that last test. Okay? That is the intuitive way of doing it. The official formula way of doing it is to say that we would take 261, which is the sum of the first 3 tests. I'm going to add a new test, and then when I add that new test in, I'll divide by 4, remember, because there's 4 tests then, and I want that to be greater than or equal to 90. And again, with algebra, we would take it times 4, and that would give us 261 plus t equals 360, which we did before, and actually this is a greater than symbol. And then I would subtract 261, and we would then get 99. Same answer, but that's the official algebraic way of doing it. Nice to do it with the intuitive way because, well, one less formula to memorize. So let's look at the next question. First 3 tests had an average of 86. 1 test left, she wants to average 89. Okay, so she averaged 86 on her first 3 tests. So what must they have added up to in order for her to divide by 3 and get 86? So if I multiply 86 times 3, those 3 tests must have added up to 258. Now, she wants to average 89 after 4 tests. So again, she wants to add up all the tests, divide by 4 to get her 89. So I'm going to go backwards and take 89 times 4. And that means all 4 tests must add up to 356. And if I subtract those two, 356 minus 258, we get a 98. And again, that must be what she scores, or better, in order to average an 89. Okay, and again, the algebraic way, because I want to make sure you have a choice, because some prefer this way, I took 86 times 3 to get a sum of 258. That's the first 3 tests together. I'm going to add a new test in. I don't know what it is. But when I divide that by 4, that sum, I want it to be greater than or equal to 89. So we'd multiply both sides by 4. And that would give us 258 plus t is greater than or equal to 89 times 4, which is 356. And then I would subtract 258, and then we would get our answer of 98. Alright, so I'm going to stop here. This is part A, so lesson 5.2, part A.